From the last video, we introduced the Pythagorean identity. So we have the sine squared theta plus cosine squared theta equal to 1, tangent squared theta plus 1 equal to secant squared theta, and 1 plus cotangent squared theta equal to cosecant squared theta. Now I'm going to do one examples from textbook 79 and talking about how to use those identities. So the question is, find all 6 trig function values given that sine theta equal to square root 2 over 6 and cosine theta is less than 0. So this time we're only going to use we are going to focus mainly using the Pythagorean identities to find the all 6 trig values. So since we have the sine theta equal to square root 2 over 6, from the Pythagorean identity, we can use the first one, sine squared theta plus cosine squared theta equal to 1 to find the cosine theta. So sine squared theta plus cosine squared theta equal to 1. Plug in sine theta. And then square the square root of 2 over 6. That is 2 over 36. So cosine squared theta is going to become to 1 minus 2 over 36. 36 over 36, which is 1. And we end up with 34 over 36. But this is cosine squared theta. We're interested in cosine theta. So to continue from this point, I also need to, I'm going to write on the top, I also need to take the square root away from the cosine squared theta. So cosine theta, take the square root. Well, becomes to square root of 34 plus minus over square root of 36. And square root of 36 is 6, and 34, it can becomes to 2 times 17. Yeah, so for right now, 34 is just the 34. Okay. Next thing we also need to consider is we have 2 answers once we take the square root, but we can only have 1. And what we know is cosine theta is less than 0. That means cosine theta eventually will become to negative square root of 34 over 6. Next, I need to find tangent theta. You can use different way to find tangent theta. Here I'm just going to do the easy way. So the tangent theta, according to the quotient identity, that is equal to the sine theta over the cosine theta. So the sine theta is square root 2 over 6. And we need to divide it by negative square root 34 over 6. Which means multiply the reciprocal. And we end up with negative square root 2 over square root 34. From the previous one, I just talked about 34, it becomes to 2 times 17. So inside 34, there is a 2. So I can simplify it, becomes to 1 over 17, square root of 1 over 17. Rationalize the denominator. We end up with negative square root of 17 over 17. Okay, for the space, I'm going to removing it a little bit. So right now, I'm just going to boxing my 6 tricks. So right now I have the problem given me on the sine theta. I figure out the cosine theta, and then I just got tangent theta. Then I need to figure out the cosecant theta, secant theta, and cotangent theta. So since I just finished tangent theta, so cotangent theta is going to be the reciprocal of the tangent theta. I'm actually going to go back to the step before rationalize the denominator. So my cotangent theta is actually becomes to negative square root of 17, or negative square root of 17 over 1. And then my secant theta is 1 over cosine theta. So my secant theta is going to becomes to negative 6 over square root of 34. This time I do need to rationalize the denominator. So I'm going to multiply square root of 34, and I end up with negative 6 square root of 34 over 34. 34 is 2 times 17, so I can divide numerator and denominator by 2, and secant theta will end up with negative 3 times square root of 34 over 17. And then the last one is the cosecant theta, which is 1 over sine theta. Sine theta is square root 2 over 6, so it's become to 6 over square root 2. Rationalize the denominator. We end up with 6 square root 2 over 2. Divide top numerator and denominator by 2, we end up with 3 times square root of 2. Okay, so for the space reason, I'm not going to rewrite the answer keys.